Welcome to the how-to video for the particle nature of light. So, light can also exist as a particle. And in 1900, Max Planck proposed that energy can be released or absorbed by atoms in discrete chunks, of some minimum size, which we call quanta. I like to think of these quanta as little packets of energy, kind of like the little sugar packets that you find at the restaurant. And so Albert Einstein kind of continued with this theory, and he believed that higher levels of electromagnetic radiation brought in more energy, which really just means that different types of electromagnetic radiation, these higher levels of it, really had sugar packets with more sugar in it, more energy. And so that was really demonstrated by the frequency. And he was able to demonstrate this through the photoelectric effect. And so we can calculate how much energy is in one of those sugar packets, or what we call the quanta of energy for a photon. And so this was really related where we could measure the energy of a single photon, where we take Planck's constant, which is given to us, times the frequency, mu. The one thing I'd like to point out is that really this energy, which we talk about, is really just the energy of a single photon. Planck's constant's given to you, and we have the frequency. But what if you don't know the frequency? What if you know the wavelength? Well, again, if we go back and remember our equation that c is equal to lambda times mu, so the speed of light is equal to the frequency times, or the wavelength times the frequency, we could rearrange this equation to solve for the frequency, which really just says that we have c divided by the wavelength. Once we know that, we could then take this and we can plug it in here for mu. That gives us this other equation, which is exactly the same thing, but when we have the wavelength, we can now still solve for the energy of a single photon using the wavelength, the speed of light, and Planck's constant. Again, it's important to understand that E is the energy of a single photon, and its units should be in joules. Because joules per second, we have frequency times Planck's constant. Per second is going to be cancel out, and we're going to be left with just joules for the energy. So frequency is in per second. C we already know, which is the speed of light in meters per second. So wavelength would also need to be in meters. That completes the how-to particle nature of light. What Planck really suggested was that we normally think of energy that just increases over time. And so different types of electromagnetic radiation could bring in energy over a wave, kind of as this continuous stream. Alternatively, what Max Planck suggested is that energy could come in these little sugar packets, and instead of seeing this steady increase in the amount of energy being delivered, what if it was just little steps? And so every little sugar packet brought some amount of energy that increased how much energy was being brought in.